Hey guys, welcome to another Maths A lesson. Today we're going to talk about compound interest. Hopefully you would have already seen the simple interest videos, or you already know what simple interest means. Otherwise, it'll be quite difficult for you to watch the compound interest video and understand what it means if you're not sure what simple interest is. Okay, so let's have a look at the definition for compound interest. Compound interest, the principle on which interest is calculated, is increased by adding the interest at the end of each time period onto the principal. So you probably still have no idea what it means. So I'm just going to give you an example and show you by example what compound interest is. So let's have a look at this example. Josh has $3,000 to save in the bank. He saves this money at 8% per annum interest for 3 years, with interest compounded annually. Calculate the future value of this investment. So basically we want to calculate how much interest Josh will earn during the 3 years time and add it onto his principal. So the way this is done is going to be quite different to simple interest. So I'll just do a quick reminder of how to do it if this was simple interest, and then I'll show you what compound interest is. So let's pretend, let's have two columns here. Let's do this problem as if it was simple interest. And let's do this problem as if it was compound interest. Now, if you remember simple interest, basically all you have to do is find out what 8% of $3,000 is. So 3,000 times 8 over 100 is 240. $240. And simple interest means that every year the interest is the same, is calculated from the principal. So $240 interest per year. Now he saves the money for 3 years, so 240 times 3 is 720. And then, so that's interest for 3 years. And the future value of his investment, so the final amount he will receive at the end is the principal plus the interest, which is 3,000 plus 720, which is 3,720. So that's simple interest. Simple interest is when every year the interest is calculated from the principal at the beginning, and for 3 years this person has earned $720 added on to the principal at the beginning, which is 3,000 plus 720 is 3,720. Now let's do this problem for real. So we are going to take into account that this is compound interest. So what that means is we're going to look at this 1 year at a time. So at the end of first year, the interest that Josh earns at the end of the first year will be 3,000 times 8 out of 100, which is $240. Now here is the difference. if you have a look at our definition from before, the principal is increased by adding the interest at the end of each time period onto the principal. So this is the interest at the end of the first time period, at the end of the first year. So we're going to add it onto the principal, so 3,000 plus 240, which is 3,240. Now that is the new principal. So at the end of the second year, what happens is when we calculate the 8% interest, we're going to use 3,240, which is our new principal, and find 8% of that. So 3,240 times 8%, and that's 259.2. And then, so our principal was 3,240. Add the new interest, which is 259.2, and we get 3,499.2. Okay, and then we have one more year, so end of the third year. Okay, so at the end of the second year, our principal was 3,499.2. Find 8% of that, and then add it on. So 3,499.2 times 8 out of 100 is 279.93. And so our final amount, which is the future value, is 3,499.2 plus 279.93. which is 3,779.14. Okay, so now we have done this question from both the simple interest perspective and the compound interest perspective. Now notice how under the same conditions, with simple interest, the future value, the final amount is 3,720, whereas under compound interest we have 3,779. So that means if you're going to invest money and the interest rate is the same, you want to invest under a compound interest arrangement, because the interest keeps adding onto the principal, and at the end you get a bigger principal. And you can also see that the interest every year is increasing as a result of increasing the principal. So the interest in the first year was 240, interest in the second year is 259, interest in the third year. So every year the interest is increasing. So that's a good thing when you are saving money, of course. When you are earning this money. Okay, so now I'm going to introduce to you the compound interest formula, which will make all of this a lot easier. So the compound interest formula. So here is the compound interest formula. And it might look a little bit complicated right now, but you will get used to it, and it gets easier once you have done a few questions. So firstly, the A is the final amount, or you can say future value. of your investment. R is the rate of interest per annum, and N is a new one, right? N wasn't in our simple interest formula, so N is the variable that we use to state the number of compounding periods per year. Number of compounding periods per year. So what does that mean? Well, you can see that here it says interest is compounded annually. So what that means is every year the interest is only added on to the principal once. So N would be 1. But for example, if it said interest compounded half yearly, then N would be 2 because interest is added on twice a year. Or if it said interest compounded monthly, then N would be 12, and so on. T is the number of years. So then using, P is the principal, obviously. So using the formula, using these variables, let's put in the values for these variables. So the rate of interest is 8%. I stated by this number here. The number of compounding periods per year is 1 because it says compounded annually, so that's 1. Number of years, so that would be 3. And the principal is 3,000, so 3,000. So putting that into the equation, we have 3,000 bracket 1 plus the rate is 8%. Oops. Eight over 100 times N. N is 1. Bracket 1 times T is 3. So putting all that into the formula. Now, when I type this in, I like to simplify it first before I type it in. So 3,000 times, I like to work out what's in the bracket first. So what's in the bracket is 8 out of 100 plus 1 is 1.08. So we have 1.08 in the bracket to the power of 3. So then when you type it in, it'll just be 3,000 times 1.08 to the power of, is this button here, to the power of 3, and press equals, and you got 3779.14. Which I believe is the same answer that we calculated before. So now we're going to do a question where the interest is compounded daily. Okay, so we always write down the formula first. A equals P bracket 1 plus R over 100 N bracket NT. And then we write P equals R equals N equals T equals. P equals 6,500, that's the principal. R equals 6% per annum. T equals 2 years. And N is, now let's have a look, compounded daily. And N is the number of times interest is compounded per year. So let me write that down so you don't get confused. Number of compounding periods per year. And obviously it'll be 365 because the interest is compounded daily. So there are 365 days in a year. So putting all that into our formula, we have 6,500 times 1 plus R is 6 over 100 times 365. Notice times 365 is at the denominator of the fraction, times 365 times 2. So there are a few calculations which I would do first before typing it in the calculator. The first is where all the times 365s are. So there's two of them. So I'm going to do this first. So 100 times 365 is 36,500. And then here 365 times 2, 730. Okay, now I would type this part inside a bracket into the calculator first. So it's 6 divided by 36500 and then plus 1, which is 1.000164. 1.000164384. 164,384. And then to the power of 730. Now notice how I try not to round this number, so put in as many decimal places as you can. So then you have 6,500 times 1.000164384 to the power of 730. So you have 7,328 0.66. And that is the future value of the investment. Okay, thanks for watching the tutorial. See you next time.